Hi, today we are going to discuss the low-level design of game of chess. In recent months, this question has been asked consistently in Amazon for HD1 and HD2 positions. Also, it has been asked in Cisco, Walmart, Oracle for individual contributor 3 position and even in Microsoft for senior software engineering position. So you can say that this has been a fairly common question across low-level design interviews. Now our goal for creating this video is to get you prepared in case you get this question in a low level design interview. What we are not going to do is we are not going to dive into the design of a large system like chess.com. We are not going to go that wide. Basically that system may have tens of functionalities and hundreds of classes. So we are not going to go there. Our goal is to learn this question, how to approach this question in case you get it in a low level design interview. So let's get started. Design of the game of chess is all about different pieces and their moves. So you have to actually figure out two things. First, how are you going to create the different pieces in a simple manner? And the second is how are you going to implement the moves of different pieces? Because each piece has got their own unique move. So what we are going to do today is we will go through all the requirements and then we are going to break our solution in multiple classes. We will also see that using factory design pattern makes it very simple to create the all different kinds of pieces, all the 32 pieces that we need to create. And then using a strategy design pattern, we are going to implement the moves and the common moves of different pieces like queen, rook, bishop. We will see it, they will be reused. So we will go through these patterns and finally we will have our completed Java code which we are going to test on this CodeZym editor. So let's get started. Let's recap the rules of game of chess a bit in case you have played it long ago. So chess is basically a two-player game. There are white pieces and there are black pieces. Total 64. It's a 8 cross 8 board, 8 rows and 8 columns. And total 16 white pieces are there and 16 black pieces are there. There are total 6 different types of pieces. We are going to, and each piece has got their unique move which we are going to say. Game is started generally by the white player and after that the players alternate turns. And on their turn a player has to move at least one piece and they can move it to either to an empty square or they can move it to an square where an opponent piece is located. When that happens the opponent's piece is killed or captured basically you can say. And also someone like a white cannot kill a white, so you cannot kill your own piece. And the game ends when the king of either white or black is captured and the party which captured the other party's king, they win. So let's see the moves. The first and the most important piece is king. If your king is killed, then game is over for you. And king can move basically one step in any direction, either horizontally or vertically or diagonally. So either straight or diagonally you can say, and one step only. Second is the knight or horse. Some places it's called horse. It is denoted by H. King was denoted by K. And a knight makes 2 plus 1 moves. So 1, 2 and left, 1, 2 right, again 1, 2 down, 1, 2 up. So basically it's 2 plus 1 moves. And the unique property of knight is that it can jump over other pieces. No other piece can do that. While a knight can jump over other pieces in its way. Finally, we have the most common piece, which is the pawn. There are 8 white pawns and 8 black pawns. And what a pawn does is it can move only forward one step at a time. So while moving, it can move only one step at a time and only forward. And when it wants to kill, then it can kill diagonally one step only. So move straight and kill diagonally. Next we have queen, which I think is the most powerful chess piece, and a queen can move any number of steps either horizontally or vertically or diagonally. So either straight or diagonally a queen can move any number of pieces. Then we have bishop, which can move only diagonally. So basically there is only one queen and there are two bishops, two in black and two in white, and they can move only diagonally. After that we have rook, which can move only straight, that is either only horizontally or only vertically, and all these three pieces actually can move any number of steps. So if you kind of see, both queen, these pieces actually share common moves. So both queen and bishop move diagonally, and both queen and rook move straight, that is left or right. So we will keep that in mind, and we will keep use that fact while designing the different moves. Now that we have revised the games of rule or rules of chess game, then let's go through the requirements. But before that, let's see how our chessboard is going to look like. So it is going to be basically 8 rows and 8 columns. And basically each piece will be represented as a string. So the first character is color of the piece and the second character is type of the piece. So WR is white rook, WB is white bishop, BH is black knight, BQ is black queen, and BK is black king. And WP is white pawn, BP is black pawn. And if the empty string means that square is empty. So you see this is an 8 cross 8 board, 64 total spaces, out of which 32 are occupied, 16 by white and 16 by black, and total 6 different pieces are there. Now let's go through the requirements. So the first requirement will be move. So in a game of chess, the core requirement is, can you move a piece from a starting position to an ending position? So first we have to check whether both these positions are valid, and whether the basically the whether the piece that is there, can it move even to the end row, end column? Is there a position piece in the way? Is there a same color piece in the way? All these factors we need to consider. So we'll see that. Next requirement is get game status, whether the game is in progress, or whether white have won it, or whether black has won it. So you need to keep track of the status of the game. Finally, you also need to get whether whose turn it is next, whether the game is over, or whether white will play next, or whether the black will play next. So you need to keep this state also. So there are not many requirements. The core requirement is the move, and then there are other requirements. So let's move ahead with the design. We are going to start with the classes which do not depend on any other class, and then we will move on to other complex classes. So the first class here is the different moves of the different pieces. So if you remember, basically we are going to take a bottom up approach here. So if you remember, both the queen and the bishop share a move, both can move diagonally. Also, queen and rook both share a move, that is both can move either horizontally or vertically. So I have kept the logic of both horizontal and vertical move in the class straight move. Both these classes, basically we are using a strategy design pattern here. So both these classes implement the move interface, which has the can move method. This chessboard class keeps all the different chess pieces, and it is initialized using the two-dimensional string array that we just saw. And diagonal move will have the logic to track whether the start and ending positions are diagonally opposite and there is no piece in between. For the straight move, it tracks two logics. The first one, either the start and ending positions are horizontally opposite or they are vertically opposite. So I haven't presented the logic here, but I will be sharing the code in the pinned comment, which will have the complete code for both these classes. So that is a simple logic. You can easily read it and understand it. So now that the moves are done, we'll see how these moves are used by the piece class or the different chess piece objects. Both the move classes that we just saw are used by the chess piece classes. That is and our generic chess piece class is the class piece. So its constructor takes a color, a type, and a list of moves. So color is basically your white or black. Type is basically your K for king. It's basically a character. So K for king, Q for queen, R for rook, B for bishop, H for knight, and P for pawn. And then it also takes a list of move objects, basically either straight move or diagonal moves. So for example, let's say we initialize it for a queen. So the move array will contain both the move objects, both the straight move and the diagonal move. And the default implementation is the can move method, whether the piece can move from a starting position to an ending position. So what this method does is, it basically goes through all the moves that it has. For example, if a queen wants to go from a starting position to an ending position, then first it will check with diagonal move whether the starting and ending position are diagonally opposite. If false, it will check the straight move, that is either they are horizontally opposite or vertically opposite. So if either using either or any of the move, if it is possible to reach from starting position to ending position, then it will return true, else it will return false. This method will be overridden by a few other classes like king, uh, knight and pawn, and it will be used by some of the classes. The generic can move method, it will be used by queen, rook, bishop. So things will become more clear when we see how the different chess piece objects are initialized and how they are using the different move classes. Not all pieces use the default implementation of can move method. For example, the king piece, it had got its own implementation. So as we saw, king can move exactly one step horizontally, vertically or diagonally. So we are checking whether the row delta is less than equal to 1 and column delta is less than equal to 1. So if it is true, then the king can go from starting position to ending position. For the knight, it makes 2 plus 1 moves, and so it checks either horizontally 2 place or vertically 1 place or vice versa, that is horizontally 1 place or vertically 2 place it can move. So again, it has got its own implementation of the can move method. For the pawn, there are two cases. When it is moving, it moves only vertically and in vertically forward, and when it wants to kill, it can kill only diagonally in the forward direction, that is diagonally left or diagonally right. So these three pieces have got their own implementation of the can move method, and let's see how all these pieces are created, and so it will bring us more clarity. If you remember from the beginning, in the beginning I said we need to take care of two problems. The first, how are you going to create different pieces? And second, how are you going to implement their moves? Or basically implement their moves in such a way that the matching or the common moves are reused. So we are going to use factory design pattern to create the different chess pieces, and let's see how it makes the whole creating the different six types of pieces. It makes it very simple, and it also makes it easy to use the strategy pattern or the different moves that we have implemented using a strategy pattern. So chess piece factory, it has basically initialized two move objects, one for the straight move and one for the diagonal move, and it will reuse them again and again. In the create piece method, so basically this method takes a color and a type and it returns a chess piece object. Okay, so if the type is queen, so color and type will be common across the pieces. For the queen, there are two type of moves a queen has: a straight move and diagonal move. And if you remember, all the move objects or the move classes implement the can move function, and that can move function is used. So a queen has got two types of moves. A rook has got only straight move. A bishop has got only diagonal move. And just now we saw that king piece, knight piece and pawn piece, these three pieces give their own implementation of the your basically can move method. So we haven't passed any move in these pieces. So their default moves will be empty and their can move method will have the overridden implementation that we just saw. And this was, in case you forgot, this was our piece class, which takes a color, type and a list of moves. If the moves is none, then it is initialized with an empty array. So now you understand how the different pieces are created and how the moves are reused. You see, we have created three pieces using two moves, and overall creating the pieces in a factory makes it easy to create. Basically, it has simplified the creation logic of different pieces. Finally, we have our chessboard class, which is basically our sort of controller class, and it keeps tracks of everything, game state and all, and it stores the whole board state and all the pieces. So in the initial, it is initialized with the 2D array that we saw in the beginning. the 2D array of strings. So what it does is, in the initialization, it converts that 2D array of string into basically a 2D array of chess piece or piece objects. So that's what this for loop is doing. It also has the chess piece factory object, which it uses to create the different chess pieces based on their code, that is color and their type. It also keeps track of game state, and it keeps track whose turn it is next. 0 for white, 1 for black. In its move method, I haven't given the code here, but you will get the code in the pinned comment. You will get the complete code. So what it does is basically it checks whether the move is valid, both the starting and ending positions are valid, and then it moves the piece from starting to ending position. It also keeps track of get next turn, that whose turn it is next, and get game state, so whether the game is it is in progress, or whether it is finished, who had won, white had won or black had won. So this is sort of our controller class, and this is basically the class which glues everything. Finally, we have our tester class, which is class solution, and this class is basically, its methods are called by the testing engine in CodeZym to test whether your code runs correctly, or basically your code runs correctly against all the test cases. So what it does is it initializes the chessboard object using this 2D array of strings that we saw in the beginning. This white rook, white knight, white bishop, black queen, black king, this array, and once the chessboard is initialized, we saw the code for initialization just now. For its move method, it simply calls the board. For the get game status, it calls the board. For the get next turn, it simply calls the board. So all it does is it simply calls the chessboard object. Here it handles only one case. If the game state is not 0, that is game is over, game is one of either white or black has won, then it returns -1, that it's no one turns next. So this is all about how we test our code. So we have completed all the coding part. Our Python code is ready. Let's go test it. Now that we have completed our Java code, so let's copy it and test it in the CodeZym editor. So this is question number 8 actually, and let's paste our Java code here. In case Java is not selected, Python is selected, then you will use this drop down to select Java. Okay. Also, do not forget to comment the helper code at the bottom. It is just meant to basically get rid of compiler errors when you code your solution in the local. So we have commented it when we are using it in the editor, and let's run it. So it will run pretty fast. Right now it is compiling, and you will see one sample test case was there and it passed. So let's submit and see that it passes all the test cases. As it keep on passing the test cases, you can see the status changing here, like code has compiled. Now it will show you the number of test cases that have passed. Every like 4-5 seconds it will update. So 7 test cases have passed here. Now all 11 test cases have passed, and it took 22 seconds. So the benefit of testing your code in CodeZym editor is that you get the confidence that your code was indeed correct. And this confidence is very important to take along with you in the interviews. If you can do this question now, you can do well in the interviews as well. So to summarize it all, if you want to design or do the low level design of game of chess, you need to take care of two things. First, how are you going to create different pieces, and second, how are you going to implement the different moves of those pieces, or basically how cleanly you are going to reuse the different moves that are there between pieces. If you can take care of these two things, you will do well in the low level design interview, in case this question is asked. Now, if you are preparing for low level design interviews, or if you have low LLD interviews in a week or so, then you should try codezym.com/roadmap. This is a 7-day preparation plan, and it will help you prepare for your LLD interviews very efficiently. It has basically all the short videos and all the theory for most common design patterns and all the most common questions that are asked in your LLD interviews. So give it a try. It will help you prepare for your LLD interviews. Basically, there is a lots of content on the internet, and you may get confused at which topics to read first, which questions to practice, where to run your tests. basically you have to see that your uh, code you have coded correctly or written code correctly for a given question. So everything you can get on CodeZym. So I wish you the best of luck for your interview preparation, and I wish you get the job and salary that you are looking for. Keep trying other questions from CodeZym and keep improving. Thanks a lot. Bye.